So what I want to do is I want to first talk briefly about slacks before we look at a practical example of the linear programming problem. So in order to explain what the slacks are, I'm going to use this formulation from the Farm-Ghana Limited for you. Slacks, we have said, are unused resources. The resources that are supposed to be used but have not been used. For example, if you go to work, you get there late at 10 o'clock, and work is supposed to start at 9 o'clock. You have wasted 1 hour. And that wasted 1 hour, that left over 1 hour, is a resource that have not been used. And whatever you do, that hour is gone. So the available resources minus the used resources gives you the slacks. It's the same as saying that the right-hand side minus the left-hand side will give you the slacks. Now, the slacks can help you to formulate the linear programming model in the standard form. The standard form of the linear programming model requires you to convert all inequalities to equalities. And that would mean that you are able to use the slacks to do that conversion. Let's remind ourselves a little bit with the Farm-Ghana Limited. I'm going to mute here. If you have a question, just raise your hand. So you have your z function, which is equal to 40x1 plus 50x2, subject to, this is something we've been using all along, subject to 1x1 plus 2x2 less than or equal to 40 hours of labor. And then you have 3x1. Is it 4x1 plus 3x? 4x1 plus 3x or 3x plus 4x? Which one? Can you type it there for me? I think it's 4x1. Is it? 4x1 plus 3x2 less than or equal to 120. Then your non-negativity constraint is that. So for those of you who remember, can you type there? Whether it's 3x1 plus 4x2. So this is the formulation. This one is the non-standard form. Now to convert this to the standard form, there are two assumptions you got to make. One, the slacks contribute nothing to the objective function. And the reason is because when you waste resources, it will not add up to your profit. Once the resources are gone, they are gone. So if I'm going to write this in the objective function by using the slacks, I will still have my 40x1 plus 50x2 plus 0s1 plus 0s2. Now, why s1 and s2? The s1 and s2 refers to only two constraints in the model. As you can see, the first constraint we have is the labor constraint, and the second constraint we have is a milk constraint. So because there are two constraints, there will be two slacks. If there are three constraints, there will be three slacks. And if there are 7 constraints, there will be 7 slacks. You normally don't include the non-negativity constraint. So with that in mind, if you are going to have the slacks, you know in your mind that there's going to be 2 slacks. The slacks contribute nothing to the objective function. That is why I need to bring 0 in front of the S1 and S2. Once the slacks are in the objective function, they are supposed to also be in the constraint. Now, the first constraint is x1 plus 2x2. But we said that in the constraint, we introduce equalities for the non-standard form. So it means that you're going to have 2x2 something equal to 40. And that something equal to 40 will be plus. Then you bring the first constraint slack, which is called S1. Now we'll come and talk about why it is S1, why it is plus and not minus. We go to the next one, which is a 4x1 plus 3x2. And this is equal to 120. The fact that you have introduced the equality sign, and of course, this is a second constraint. So you will now do plus S2, where the S2 stands for constraint number 2. And then you have equality symbol. So in this context, why is it plus S1? And that is because the inequality sign is less than or equal to. When the inequality sign is greater than or equal to, we are going to have minus S1. When it is less than or equal to, you're going to have what we have. Once you are done, you now write the last constraint, which is a non-negativity constraint. But this time, you also include the slot. So you have x1, x2, s1, s2. Then you have your usual non-negativity constraint. This is how you execute. This is exactly how you write the whole thing in the standard form. That's it. Always learn to write the model in the standard form. It's the best way of writing the model. Okay. Now, what is a slack? So obviously, we can see that in this context, if you want to find the slacks, to find S1, you have to move everything to the right-hand side. Okay, you have to move everything to the right-hand side. That is why we always say that the slacks are the available minus unused. In this context, available is the 40, the unused is the x1 plus 2x2. So you always learn to deduce the power of the slacks from the available as well as the unused. Okay, so I wanted to bring on that before we go to the practicalities of multiple decision variables. All that we've been doing, we have been dealing with just single 2 decision variables, x1, x2, x1, x2. So you can see that this is how you write your slacks. As you can see, this is the slacks. And all you are doing with the slacks is that you are introducing equality. Once you do that, you are introducing equality. Now, what do you think are the values of the slacks at the origin? Okay. If you look at the slacks, what do you think are the values of the slacks at the origin? Remember that at the origin, you are not producing anything because at the origin, the x1 is 0, the x2 is 0. So what do you think are the values of the slacks at the origin? Who can tell me? You can raise a hand and tell me. What are the values of the slacks at the origin? Raise a hand and tell me. Okay. Redeemer, unmute yourself.
Hello, sir. So we are in the class at UGBS, so we have raised our hands, but we don't know how to communicate with you. But the class for milk will remain the same, then the same for labor.
Okay.
So that's
Exactly.
40 Wednesdays.
Exactly. I mean, next time what I can do is I can make an arrangement to talk to all of you through the computers. Okay. The TA Mimi can make that arrangement. So just work with me, with her on that. So yes, the slacks are going to be equal to the maximum value of the x1 and then the x2. The slacks will surely be maximum. So the labor slacks will be 40 and the milk slacks will be 120. So everything that is available will become the slacks because you are not producing nothing. So what it means is that you have wasted all of the resources. What do you think? You can type it, by the way. You can type the answer in the chat. What do the slacks contribute to in the objective function? What do you think the slacks contribute to in the objective function? Well, I've said it before. The slacks contribute to nothing in the objective function. And the reason is that the slacks are wasted resources. So once you wasted a resources, they don't add up anything to the objective function. All right. So that is what I wanted to just show you regarding these slacks before we go to the purpose of our work today. So I'm going to look at a practical example of linear programming. By the way, opposite of the slack is the surplus. If the slacks are unused resources, the surpluses are excesses above the existing contribution. I've also told you to look at irregular types of linear programming. So please, I've sent you the video on that. Watch it and look at it, the irregular types of linear programming. Look at them carefully yourself, okay, so that you do not get surprised at any point in time. My focus for today is to show you a practical example of linear programming problem. This example is known as the investment problem of Ama-Benyuado. The investment problem of Ama-Benyuado. Just some of you know her. So I'm going to look at this, and I want you to take your pen and paper and follow through because you might meet this somewhere in your exam situation. Ama-Benyuado is an individual investor. She has 70,000 to divide among several investments. The alternative investments are municipal bonds, which is MB. And this would generate an annual return of 8.5%. There is another investment, which is the certificate of deposits, CDs, with an 5% interest rate. Treasury bills, TD, with a 6.5% interest rate. And a growth stock fund, like a mutual fund, like M fund, with a 13% interest rate. The investments are evaluated after 1 year, but each investment has a perceived risk to Ama, the investor. So it is sensible to diversify this portfolio. That is why you can see that there are 4 different derivative instruments. Ama wants to know how much to invest in each alternative investment structure in order to maximize, not profit, but rather maximize returns on the investment. Now, there's more information. The following guidelines have been established to diversifying the investment in order to lessen the risks perceived by this investment. The first guideline is that no more than 20% of the total investment should be in the municipal bonds. So don't put more than 20% of your total investment. We know the total investment is $70,000. The amount invested in certificate of deposits should not exceed the amount invested in the other three alternatives. 3, at least 30% of the investment should be in treasury bills and certificate of deposits. 4, in order to be safe, more should be invested in certificate of deposits and treasury bills than in municipal bonds and growth stock fund by an average of at least 1.2 to 1. And finally, AMA wants to invest the entire investment. This is the problem of the day. The problem of the day is worked by using your intelligence and your thinking faculty and trying to understand what you have right now. So let's get started. What do you think is the first thing to do with this investment problem? Don't look at it from investment. Look at it from a programming, linear programming point of view. What is the first thing you have to ask yourself? Who can tell you? What is the very first thing you have to check? By the way, what is objective of AMA? Like I said, you can type it there or you can raise your hand. What is AMA's objective? Okay, Benjamin.
It is to maximize returns.
Maximize return. That is objective of AMA, to maximize return. So never forget objective all the time. Now, what is the first thing you have to do in order to address this objective? You have to identify something. Anytime you're doing a linear programming, your goal is to identify something. What are you supposed to identify? The teacher says to maximize returns. Dinah says to identify the decision variable. Well, to be honest, Dinah, that is the best answer. The best answer is to identify the decision variable. Identify the decision variable. Now, what are the decision variables? You have to first say, let this, that. So who can tell me, let what be what? What, how you interpret, you check the past. This was once upon a time, giving us an exam question. How you write a decision variable is very important. So how do you identify the decision variable? Who can tell us? Or you can type it in. How do you identify the decision variable? Benjamin.
So you have to let S be the municipal bond. That needs to be maximized, or AMA needs to invest. And then S2 will be the certificate of deposit. And then maybe S3 will be the...
Benjamin, hold on. If that is how you are going to identify the decision variable, that will be wrong. There is a unique way you have to identify the decision variable. There is a special way. How you write it matters. Richard.
So let X1 be the percentage of the annual return on municipal bonds. Then you do the same thing for all the three, X2 for.
No, that
Yes,
wouldn't
sir.
be the right way to identify the decision variable like that. Gideon.
So say, let X1 be the investment return on a
S1
municipal.
cannot be the investment return. That would also not be correct. Who's going to crack this for us? Benjamin.
Okay. So let S be the amount, S1 be the amount of municipal bond AMA will invest.
Say that again.
X1 will be the amount of municipal bond.
Check the English. Okay. So, you see, you have to know what you are looking for. Before you can maximize your return, you need two things. Okay. The first thing you need, I'm going to write that here for you to appreciate it. The first thing you need when you are maximizing your return, let's say, that return is given by R. Of course, we'll change it. It is Z here. You cannot maximize your return unless you know the interest rate. So first, you should have the interest rate in mind. You multiply the interest rate by the amount that you are investing. By the amount you are investing. This amount you have put in plus the interest rate will be your return. Do you agree with that? So if the interest rate is 10% and you invested 10,000, you're going to have 10% of 10,000. And 10% of 10,000 is going to be 1,000. So your return will be that 1,000. This is how you have to think the thing. So what we need to note is that what you have been given here are the interest rate. Okay, that's the interest rate. So to get the actual return, you need to know how much you have to invest in because you know the interest rate. So your decision variable is rather going to be let X1 be the amount of money invested into municipal bonds. You don't just say municipal bonds. If you say municipal bonds, that's wrong. That's rather the amount invested into municipal bonds. What will be X2? The gates of heaven is open. What will be X2? Franklin, were you saying the right thing or you were guessing? What you've written? Were you saying the right thing or you were guessing? What is X2? Yes, Joyce.
Let X2 be the amount invested certificates of deposit.
Okay. You know, you don't have to say let X be again. You have to continue by saying that X2 is the amount invested into the certificates of deposit. Then the S3 will continue. Then the S4 will continue. And you need to have all of these nicely written. To be honest, if they are not nicely written like that, you will lose everything. So I beg of you to take note of this. So in terms of the first thing to note, that is how you write your decision variable. I've told you this over and over again. The first thing in linear programming formulation is to identify the decision variables. Use proper language to do that identification. Use proper language. Okay. Now, you might say what I have here. Let Xi be the amount to invest in each of the 4 investment alternatives, where I is 1 to 4 because there are 4 investment opportunities. That's another way you can write. But we always prefer the first one we've all said. So now you know that what you are looking for is how much to invest. How much Ama Benuado has to invest. That is your X. Using that, you should be able to write your decision, your objective function. So how will you write your objective function? By the way, are we maximizing or minimizing? I know you know already. Who can tell me how do you write the objective function? Or if you want to type it there, how do you write your objective function? Yeah, Benjamin.
Okay, so maybe because we can't work with the percentage, so maybe we change the percentages. We divide them by 100.
Okay.
Yeah, so maybe we are maximizing. So ZM should be scored to 0.085.
I should write ZM.
Yes, please.
I should write ZM.
Tmax, sorry.
Okay.
Should be scored to 0.085 X1.
Okay.
Plus 0.05 S2 plus 0.065 S3. And then 13 divided by. So plus the.
About the last one. So this is how you have to write your objective function. This is how all of you have to write your objective function. This objective function is 5 marks. And please remember that under exam condition, you will always have more than 4 decision variables. It's not going to be 2 or 3 or 4. It's going to be more than that. So be used to that. Get used to that. Okay. This is objective function. Now, who can tell me what this one I have circled, what does it mean? What is the one I've just circled? The one I've just circled, what does that mean? What is that? The story is also in front of you. What is the one I've just underlined? Benjamin.
One is visible, but it is the amount we invest to have 0.5 returns on.
Okay, that is not really that. You can tell me what I have circled. What is this standing for? What is a Harold?
The certificate of deposit, the coefficient of exchange.
Again, Harold.
Hello, sir.
Your network is dropped. That's why.
That's certificate of deposit.
All right. So it is the amount, it's not even amount, it's a total return obtained from investing in certificate of deposit. Is a total annual return obtained from just the certificate of deposit. That is what I've circled is. And that return is obtainable by multiplying the interest rate by the amount invested in certificate of deposit. Note what you are doing better. All right. And you can say the same thing for other. That is why the whole of this is the total investment return. Now that you have formulated objective function, let's go to the constraint. Constraint number 1. It says that no more than 20% of the total investment should be in municipal bonds. Municipal bonds is X1. So if you don't take care, you will not be able to formulate this well by fumbling. Once you have percentage here, use that. Who can remind us of the total investment? What is the total investment? 70K. So now you have to go and calculate 20% of the total investment because that's what it's saying here. What is the 20% of the total investment? Let me see what some of you have written. 14,000. Joyce, that's correct. Now this 14,000, you are about to identify where you would write that 14,000. You write it to the left or to the right. No more than. So you got to understand the meaning of the word no more than. First of all, what is more than? What symbol is that? And second, what is no more than? Well, let me just take you through some quick exercise so that you can always have, because you tend to get these things a lot when it comes to. So I want you to look at these symbols here. This is just a reminder of how your English is good compared to how your stars is good. We all know that this symbol, if you have to mention it, this symbol, what symbol is what I've written here? What symbol is that?
Less than.
Less than.
What is the opposite of this less than?
Greater than.
Greater than is wrong. Opposite of less than is not greater than.
Greater than or equal to.
Well, now it will surely be greater than or equal to. It's lottery. If you are doing lottery, you would now try and luck, and then whichever one works, you think that that is correct. So the opposite of less than is greater or equal to. What you should know is think about why that is so. And then, of course, the opposite of greater than is less than or equal to. However, there are some English words that can mean less than or equal to if you look at them carefully. For example, what symbol is below? What symbol is that? Okay. Dinah says it's less than, and that is correct. What symbol is beyond? What symbol is beyond? Joyce says greater than, and that is correct. What symbol is fewer than? What symbol is fewer than? Joyce is getting it correct, unlike the others. Okay. Is that what Joyce said? Okay. If
Greater than
your
or
answer
equal
is
to.
the recent one, that is wrong. Fewer than is greater or equal to. Now, one of the advice I'll give you when you're trying to do this is that remember that fewer than itself is less than. Fewer than is less than. The opposite of less than is greater or equal to, which is a not fewer than. Which is a not fewer than. So anytime you're having not, try and put the not on the aside and deal with the word. After that, bring the not, because the not is the opposite of the symbol. Okay. What symbol is the same as? The same as. That is equal to. What symbol is not above? Not above. Less than. Less than is wrong. It is less than or equal to. Joel, your answer is the best answer. Okay. What symbol is better than? The fact that some of you are getting it wrong should tell you that you should sit up. Better than. Better than is greater. Good. What symbol is worse than? That is less. What symbol is at least? What symbol is at least? At least is greater or equal to. What symbol is at most? Less or equal to. What symbol is not at least? You can tell me. What symbol is not at least? Excellent, Joel. That is greater than. And then, of course, younger than is less than. So not younger than is greater or equal to. What symbol is above? Greater than. Not different from. Equal to. And then differs from. Not equal to. So you should know all of these on your fingertips. So let's go back here to what we're trying to formulate regarding these. It says that no more than 20% of the investment. So that symbol, what symbol is no more than? What would it be? Now you're applying. What symbol is no more than? By the way, no more than is just like saying not more than. That is, let me see the answer. Franklina says less than or equal to. That's correct. Okay, so no more than is less than or equal to. Now that you have calculated your 20%, which is 14,000, you have to put that on the right-hand side. Why? Because it says no more than 20% of the investment should be in the municipal bonds. So the maximum that can be in the municipal bonds is 14,000. No more than that is required. So how will you write the left-hand side? You have to think about what municipal bond is. What is represented by municipal bonds? That's X1. So you now write on the left side, X1. You have been able to formulate the first constraint. Let's go to the second constraint. The amount invested in certificate of deposit, which is X2, should not exceed the amount invested in the other three alternatives. What symbol is should not exceed? What symbol is that? Yes, I got an answer from Joyce. Again, Joyce, you really contribute. So should not exceed is less than or equal to. Fantastic. Now, watch the words carefully. Should not exceed. So first of all, what we are going to should not exceed is less or equal to. Now you are told that certificate of deposit should not exceed the other three. What symbol is certificate of deposit? When you were writing your let X2, X1, X3, what symbol was for certificate of deposit? Benjamin says X2, and X2 is correct. You know, I can write all of these things without asking you. So you have X2. And then it says that whatever is being put into X2 should not be more than the others. What are the others? The others are going to be on the right-hand side because what we are having should be less than or equal to. It says that it shouldn't be more. So you write X1, which is the first one, X3, which is the second one, X4. So these are the other three. And you can move the ones on the right-hand side to the left-hand side so that you can have a very nice equality symbol. To do that, that is going to be X2, or you even do minus X1 plus X2 plus X3. Sorry, minus X3. You're moving them to the left-hand side of the endpoint. Minus X3. Minus X3 minus X4. Less or equal to Z. No, not less than or equal to. This is going to be, yeah, less or equal to Z. Let me see. Yeah, less or equal to 0. Remember that you have not divided or, you have not divided anything by anything. You are only moving. You are not moving whatever is on the left-hand side to the right-hand side. All right. So this is how you formulate the second constraint, the amount invested in. Let's go to the third diversification constraint. In fact, let me show you here. The first diversification constraint, by the way, this is all that I did there, is saying that at least 30% of the investment should be in treasury bills and certificate of deposit. That's least. What symbol is at least? What symbol is that? Greater than or equal to, that's the correct one. Okay. It's greater than or equal to. So you have that in your mind. Now, it says that 30% of the investment should be in treasury bills and CDs. So, treasury bills was represented by what? And CDs were represented by what? I need to be sure you know what you are doing before we calculate the rest. Treasury bills was represented by what? Because you remember exactly what it's done. Treasury bills is X3, and certificate of deposit is what? X2. Okay. So if you are to write this, what you are saying is that there is X2 and that of X3. And the investment should be at least, don't go below. 30% of the investment should go into this combined. So we need to calculate again 30% of the investment. So someone should give me the value for the 30% of the investment. 30% of the investment. That is 21,000. Okay, so you write your 21,000 as the maximum. That is the maximum amount that you are going to write, because at least means that from 21,000 and above should go into this. Okay, 30% of the investment should be in these two. So any amount that you are going to put into these two, X2 and X3, these amounts should be more than 21,000, or in the least possible case, it should be equal to that amount of 20,000. That is how you do this third one. And of course, when you scroll down, you will get it like this. We are left with the last one. It is one of the toughest formulation ever to stop, but is doable. The ratio of investment in certificate of deposit and that to the investment in municipal bonds and growth stock fund, the ratio should be at least 1.1 to 2, 1.1 to 1. The word ratio means that we are going to have some fractions. That's what it means. We're going to have some fractions. The other thing is that it is 2. So we are going to have a fraction of something to something. And the word 2 here means divided by, in case you don't know. The ratio of 17 to 18 is 17 divided by 18. So when you understand how this works, you will know how to formulate it. So let's look at the certificate of deposit and growth stock fund. The certificate of deposit is X2. Sorry, the treasury bills is X3. Okay, or rather the other way around. The treasury bills is X2, and the certificate of deposit is X3. Okay. So how do you write that? You have certificate of deposit, which is X3. You have treasury bills, which is X2. So we are going to have the first ratio to be like this. The first ratio should be equal to, or should be, X2 plus X1, X3, divided by, normally it would have been divided by 1.2. But it's a ratio. It's a ratio of that to investment in MB and GIN. So what is investment in MB? MB is X1. GIN is X4. And this should be equal to, because he's saying that it's a ratio. So it should be equal to the ratio of what they gave us, 1 to 2, 1.2 to 1. So this should be equal to the ratio of 1.2 all the way. Where is the thing now moving? 1.2, okay, good. You're going to have now 1.2 to 1. This is how you write your ratio. But you are not done. You need to group items. So the whole of here by cross multiplying, basically. Okay. And in the cross multiplication, you're going to have X2 plus X3. Then you bring these ones to the left-hand side, minus 1.2 minus 1.2. Okay. Now the first one is multiplying, but because I don't have anything, it's just 1 they are multiplying. I just leave it like that. But to the second one that is multiplying, you are going to take 1.2, multiplying both X1 and X plus X4. That's it. Expand and group items. When you expand and you want X1 to come first, you're going to have X negative 1.2 X1. When you move to the left-hand side, then X2 which is a plus. Then X3. And then the last one is X4, which is minus 1.2. Then you do your less than or equal to, you write your 0. That's the same thing you would have normally done in the Excel to get a result. If you to do all of these very nicely, you're going to get something like this. Okay, you're going to get something very nice like what I'm tossing to you right now. Any question on this before I move on? Any question? Any question? You should learn how to formulate. Learning how to formulate is a foundation of this course. All right. Now, let's take everything. Let's take everything. Oh, by the way, you don't forget your last constraint. There's a fifth constraint. It says that Amma invested everything. Go to the story. It's always good to read and reread your story carefully. It says that Amma wants to invest everything, 70,000. Who can tell me what would this constraint be? Amma wants to invest everything, 70,000. What do you think this would be? All the investment. If Amma is investing everything, it means you add everything together. That's what it means. Okay. Everything should be added together. And what does that mean? What it means is that you would take your X1, you add it to your X2, you add it to your X3, add it to your S4. And then Amma is investing in everything. It's indication that all of this combined should be equal to 70,000, not equal to. Not that. So you are supposed to invest the entire thing. Everything must go. Okay. So this becomes the right-hand side of another constraint, and the left is all of this. You got to understand it. And this is the last constraint. Once you have the last constraint, don't forget your non-negativity constraint. In this case, the decision variables are how many? There are 4. Make sure none of them get lost. Else you won't get a right result. So let's put everything together here. Okay. So there's a non-negativity constraint. There are 4 of them. Don't forget. Everything that you see is as a result of thought. Everything you see is as a result of thought. Guys, should I give you some time for break? So that you don't... Should I give you some 5 minutes for break?
Yes.
Okay, good. I'm giving you some 5 minutes.
Yes.
So this is a model. I'm going to do it quickly in Excel. So quickly in Excel that you can go along with me. But I'm going to fly. And then we'll answer some questions. Okay. So I'm going to show you my Excel screen. Please confirm if you can see my Excel screen. Can you confirm? Okay. So this is a model that you have. Your eye must always be in the model whilst you are formulating. On the top left corner, I'm going to call the name of the person, Amma. Then I'm going to write the decision variables. The decision variable, the first one is municipal bonds. The second one is Which one is the second? Is it certificate of deposit or treasury bills? CD, treasury bills, and then gross stock. Is that it?
No, CD first.
Which one is first?
CD second.
Treasury bills is second.
So MB is first, CD second.
Master, are you watching what I've put there? Just watch and confirm whether what I've put there.
Good.
The way you spoke, it looks like you're not even looking at what I have. Your friends are saying that it is correct. And now you are also, all right, so let's move on. Now, look on my screen. It looks like some of you have put your phone somewhere, your laptop somewhere, and you're doing something else. Now, let's write the coefficient. So this is the coefficient, and the first coefficient is 0.085. Always check your model whilst you write. The second coefficient is 0.05. The third coefficient is 0.065. And the last one is 0.13. These were the coefficients. The decision variables was amount to invest. Okay? The amount to invest. We don't know them, so we initialize their values to 0 for all of them. Now we need to write the Z value. So on the right here, I'm going to write the Z value, which is the total investment. Total investment will be Z. Okay. You will take the coefficient, you bring your times, take the decision variable, press the F and F4 key. Press the F and F4 key, plus take the second one times the decision variable, press the F and F4 key, sorry. Take this one and then press the F and F4 key, plus take the third variable, do times, select the decision variable, and then do your F and F4 key. Then the last one plus, take the last coefficient, multiply that coefficient by the decision variable, press the F and F4 key, enter. Now let's go to the constraints. Okay. Constraints. Now in this constraint, under that, you write the first constraint because they have most of the constraints are mixed constraints, and because they are mixed constraints, you just have to write C1, C2, C3 to represent the constraint. So the constraint 1, we are calling it C1. Constraint 2, we are calling it C2. Okay, and then all the way up to the constraint 5, like that. Now, we need a sign, and in the column F, the next column should be for the sign. So you type sign here, and then the right-hand side will be here, right-hand side, which is also available. The left-hand side will be here. And now we are ready to put in the numbers for each of these constraints. You go and check your objective. Look at it. X1 is the only one that is in the first constraint. The right-hand side of that constraint is 1400. So you type 1400 on the right-hand side. Okay. Now, the only one that is there, and this is the column for X1. The only one that is there is X1, and the value was 1. So I type 1. As you can see, X1 is the only one there. There's no X2, X3, X4. You go to the next constraint. The next constraint, X1, is -1. So still under X1, write -1. And then what about X2? X2, you can see in this constraint is 2, is 1. So you type 1 x2. x3 is -1. You can see it here. x3 is -1. x4 is also -1. So you do -1, you do -1. Okay. Now the right-hand side, as you can see, is 0. So you type 0 here. Let's leave this side for now. Let's go to constraint 3. Constraint 3, there is no x1, but there is x2 and x3. So you leave x1, go to x2 and x3. When you check, there's only 1, 1, 1 in front of them. So x2 is 1, x3 is 1. There's no x4. What about the right-hand side? It's 21,000. So you type 21,000. Go to constraint 4. Constraint 4, x1 is -1.2. So you type it there, -1.2. x2. x2 is 1. x3 is 1. So you type it there. x2 is 1. x3 is 1. And then the x4 is -1.2. So you type -1.2. You are formulating now. Then the right-hand side is 0. So you type 0. You go to the last constraint. Remember, the last constraint is the one, I invested everything. And on the right-hand side of that is 70,000. But on the left-hand side is 1, 1, 1, 1, 1, as you can see in the model. Always look at the model. So now we go to the model, type 1, 1, 1. Okay. And then on the right-hand side, you type 70,000. That's it. Now, what sign are you using? Look at the sign. The first one, the sign is less than. The second one is less than. Third and fourth are greater than each. So you just do this less than, just beautification. Then the right, greater than, you also do it for beautification. But the last one is equal to. So bring a dot before you do the equal to. Who can tell me why I brought the dot before I brought the equal to? Who can tell me why I brought a dot before I brought the equal to? The reason is because if you just bring the equal to as it is in the model, okay, you bring the equal to, Excel will see it as a formula. And you don't want it, it's just for beauty. You are finished formulating. Now go and copy this one here. Okay. Copy and paste it into the first constraint. And when you double click, it should be collecting the values. So it's fine. You cannot click and drag it to the others, as we always do. It means that when you click on each one, because of the dollar symbol, each one is multiplying the decision variables. You are done. To do the model, go to data on the top, data tab. On the far right, choose solver. Okay, choose solver. Then by changing cell, the first thing to do is look at objective. The objective is a Z value. Right now, you should delete whatever is there and go and select the objective. The objective is this value here, F2. So select F2. It's a maximization, so leave it like that. By changing cells are the decision variables. So click on the by changing cells and select all the decision variables. Click on the subject to constraint. And look at the subject to constraint. It has the left-hand side and the right-hand side. Click add. The constraint parameter dialog box will come. The left-hand side, if you can see the sign, okay, the first two have got the same sign. So I'll put them together, drag the two of them into the left-hand side. Then click the right-hand side, drag the two of them on the right-hand side. And then choose the less than or equal to sign. They're done. Click add. The thing will be empty again. Go and select the next two. They are all having greater than, greater than. So go to the left-hand side, select these two. And then the sign is greater than, so click and choose greater than or equal to. The cursor goes to the next right-hand side. Click the 21 and the 0 into the right-hand side. You're done. The next command is the last one. So click add again. And then select that singular one, which is 0 on the left-hand side. On the right-hand side, click 70,000. The symbol between them is equal to, so choose equal to. And now you are done. You don't need to click add again. You just click OK. Now, if you don't understand, stay here. I have seen over the years that when a person does not understand, then they leave the Zoom. That will be tantamount to your everything wrong. Stay. Life is not a straight line. Okay, it took 30 years before Dangote became Dangote. It took over 20 years before Jeff Bezos became Jeff Bezos. Success is not a comfortable procedure. You will never be able to understand everything immediately. It has taken some people a long time to be able to get this thing immediately. So stay on. A little will go in. Instead of leaving because you don't get it. This is where people fail in life. And I see that failure is caused by you. I never did that. Anytime I am taught something and the thing is hard, I stay on. I stay on. I press on. I stay. I do it. And then I'll go over it again. And I'll go over it again. You're not different from me. I'm not different from you. If I could do it, you could do it. You always neglect yourself, destroy yourself from the premises. Okay? And you devalue who you are. Meanwhile, you two were created in the image of God. So this whole mentality that when you're learning something is a little bit harder, my bad, I'm tired. Don't do that. Your future self will not even forgive you. Students are like that, and I've seen it. So it's possible that somebody is even sleeping. Somebody has gone to sit somewhere. Somebody is chatting somewhere. It is wrong, I'm telling you. You either win or you perish. That's life. Okay? You either win or you perish. All right, let's move on. Make unconstrained variable non-negative is a non-negativity constraint. Click simplest algorithm and move. I told you, go over this if you want to run it. If you look at assignment I've given you, you have to go through all of this by yourself. Go over it, run it, and solve it by yourself. Anyway, we're about to click solve, and then choose sensitivity, and click OK. Restore original values, and click OK. The new sensitivity report has just been created. This is a sensitivity report. And these are the ones that you are going to ask some questions related to all of this. Now, let's try and see whether we have been able to make sense of what we have here. I'm going here. Everything I've done is in the slides. Step by step, I've copied, pasted everything in the slide. Go through it step by step and run the model yourself. I would do it if I was in school. I would go through this, sit down in front of my computer between 2 a.m. and 6 a.m. I would do it. You are not different from me. I'm not different from you. If I can do it, you can do it. Whether you have children, you have grandchildren, you have papa children, you are committed. You are committed. You either win or you perish. Okay. Now, this is the result that we have. The first question, looking at the result, using the sensitivity report, what is the optimal solution to the investment problem? What is the optimal solution to the investment problem? Who can raise a hand and tell me, how do you get the optimal solution to the investment problem? This is a result. What is the optimal solution to this investment problem? What is the optimal solution? Where do you even get that answer? What is the optimal solution to the investment problem? Well, we always say that the optimal solution is obtained. If you check last time video, the optimal solution, you get them from the final value of the variable cells. The final value of the variable cells. So the optimal solution, you don't need to talk about those that are zero. Okay? If they are zero, you ignore them and talk about those that are not zero. So you say that the optimal solution is to invest in Treasury bills 38,181.82. And also invest in the growth stock fund, which is 31,818.18. That is the optimal. If you invest in only these two instruments, you will maximize your return. So it means that don't put any money into municipal bond, don't put any money into certificate of deposit. That is what it means. Because that's it. And you don't even need to talk about it because they are zero. So that is how you answer The first question. This question is always coming. The question where you have to pick out the optimal solution or the quantity of products to produce in order to maximize profit or return or the objective value. You will always get that question. Next question. Find the corresponding maximum investment return. Who can tell us that? The corresponding maximum investment return. How do you get that? You see, the word corresponding means that you have to take it from the previous question. What is a corresponding maximum investment return? Who can tell me? How do you work it? Tell me how to work it. The corresponding maximum investment return. Charles.
You multiply the final value and the objective coefficient and sum them.
Excellent. So you take these two. So what he is trying to say is that if you want to find the z, take this z, bring equal to, and then take this value here, multiply it by the next one, this corresponding objective coefficient, plus take the next one here, multiply it by its corresponding objective function here, and that gives you the z value. Okay. Right there, it's right. Yeah, I think so. I think I didn't do something. Okay. So let me just put a bracket in there. Then or you can even use some product for it. That's the same thing. Okay, so oh yeah, of course. That's a return that you are going to get 6,680. So that is how you execute that very part of the question. Next question. Was the entire amount of money actually invested? Who can tell us? Look at the result. Was the entire amount of money actually invested? In fact, there are almost 2 ways or 3 ways of answering this. Was the entire amount of money actually invested? Was the entire amount of money actually invested? Now, do you remember which constraint captured the entire amount of money was invested? Do you remember which constraint? I've labeled the constraint as C1 to C5. Which constraint was that? Was the entire amount of money actually invested? Which constraint was that? Which constraint to guide it? Okay, constraint 5. Okay, good. So now there is something about constraint 5 that should tell you that the entire amount of money was actually invested or was not actually invested. What is that? Well, what you do is I check the left-hand side. The left-hand side is 70,000. Okay, that is here. When you look at it, you see that the left-hand side is 70,000 here. And then the right-hand side is also 70,000 there. So that should tell you that the entire amount of money was actually invested because what was available was used. What was available was used. So that the answer is yes. Okay, the entire amount of money was actually invested. But there's another way you can tell that the entire amount of money was invested. Who knows how? Another way is by checking this one here. If the amount of money invested in the treasury bills and growth stock fund, these two, when you add the two, it will be equal to the 70,000. Look at the bottom here of my cursor, and you see that the sum is 70,000. So when you add those two amounts, you can see that they add up to 70,000. A clear indication that the entire amount of money was fully, actually invested. That is how you answer questions like that. Let's go to the next question. And I've said that this one I've given the answer here. The last constraint, the left-hand side and the right-hand side are the same. What is the sensitivity range for municipal bonds? Let's go to municipal bonds. Municipal bonds. What is the sensitivity range for municipal bonds? Let's take the municipal bond in the variable cells. This one here. What is the sensitivity range for municipal bonds? What is the lower bound? Remember that the sensitivity range is given by lower bound less or equal to, okay, the sensitivity range for, in this case, municipal bonds, less or equal to then the upper bound. This is how you normally have it. So on the basis of this, what do you think is the lower bound? The lower bound for the sensitivity range. It is always taking the objective coefficient and then subtracting the allowable decrease, and then taking the objective coefficient and adding the allowable increase. Now, the allowable decrease is 1e plus 30. That number is infinity. So when you take the objective coefficient minus infinity, what do you get? Well, you know it. If you take this value here minus that value here, you're going to get negative infinity. But remember, we don't endorse non-negativity. Okay, you just watch. So you see, what you have here is going to be negative infinity. By the way, anytime you have something like 1e plus 30, e plus 30, e plus 30, okay, anything e plus 30 is infinity. And if it is negative, you're going to get negative infinity. So the lower bound is going to be negative infinity. What about the upper bound? The upper bound is going to be this same value here, coefficient, plus the allowable increase. Okay. The coefficient plus allowable increase. And you get 13%. But, guys, take note. You never have to write negative. So anytime you have a sensitivity range that has negative, start from 0. Make the negative 0. Because remember, one of the rules of the linear program is non-negativity. So if it is negative, even though it is a sensitivity band, still make that negative value 0. And then the positive value will remain as positive. So it means that the sensitivity range is actually going to be this. If we were to write it officially, okay, the value is going to be 0 on the left-hand side, and then 13% on the right-hand side. This is how it's going to be. And that is how you get, what does this mean? Who can tell us, what does this really mean? What this means is that as long as the interest rate for municipal bond is dancing between 0 and 13%, as long as that is happening, the optimal solution of these two values will not change. As long as the interest rate, but the moment the interest rate exceeds 13%, the optimal values change. Of course, we know the profits change. We know profit will change. These are questions you'll be asking. This is the real exam. These are the real exam questions. Okay, let's go to the next one. The next one says, which diversification mix will yield the most return? Now remember that the diversification mix are all in the constraint section here. All the constraints, they make up the diversification mix. So if you are asked which diversification mix will yield the, the greatest of return, you are going to look at C1, C2, C3, C4, C5. What will you have to use to guide you to do that? Who can tell me? Which diversification mix will yield the most return? Which one? How do you know? What you got to do is to use the shadow price. Use the shadow price. So all of these have got a shadow price. This third one has got a shadow price. The fourth one has got a shadow price, which is negative. So you don't go there. So the one that has a positive shadow price, the one with the highest shadow price, that is the one you are going to deal with because that will give you the biggest return. So remember, we yield the most return. So it means that the diversification mix that will yield the most return is C5. Why? Because it means that if you should increase the entire amount invested by one, unit, okay, it means that the returns will increase by 0.95 units. That's what I mean. Okay. If you should increase it by $1,000, you multiply $1,000 by this. If you increase it by $1, you multiply the $1 by that. And therefore, it is the only one that will increase the total return. It's the only one that will increase the total return. And therefore, it's the one with the greatest diversification. And you can see the answer is here. It has the highest shadow price. Which constraints are binding and why? So look at a constraint. Can you tell me which constraints are binding? Can you give me which constraint is binding or are binding? Can you give me one? We have C1, C2, C3, C4, C5. Which constraints are binding? Which constraints are binding? C5 is binding. That is correct. Which other one? Patrick says C5. Which other one is binding? And that is true. C5 is binding. And the reason why C5 is binding is because the left-hand side is equal to the right-hand side. So that's why it's binding. C4 is also binding because the left-hand side is equal to the right-hand side. That is why it's binding. Okay. No other diversification mix is binding. No other constraint is binding apart from these two. That is how you attack this question. Next question. If Amma has a choice of investing in municipal bonds or certificate of deposit, which should she choose and why? Amma has a choice of investing in municipal bonds or certificate of deposit. Now that question is actually from this constraint. In case you have forgotten, the constraint 3, the constraint 1 was about municipal bonds. The constraint 2 was about certificate of deposit. I will explain that by taking you to the model to appreciate it well. If you look at this very example here, watch it. Here I gave the actual names. So municipal bonds is the first constraint. Then the second constraint is certificate of deposit. So if you look at this, the question is asking you that which of these two, the first is municipal bonds, the second is certificate of deposit. The question is asking you which, where is that? Okay. If Amma had a choice of investing in that municipal bonds, the first constraint, and that certificate of deposit, the second constraint, which one should she go for? Which one? The answer is none of them. Who can tell me why none of them? The answer is none of them. Who can tell me why none of them? There are two reasons you can pick. The first reason is that when you look at the shadow prices, both of them have a shadow price of 0. So whether you invest in any one of them, you top up or invest in any of them, it will yield a zero shadow price. In other words, it will add nothing to your total investment return. Another way of also checking that is looking at their reduced cost. You cannot invest in any one of them because the opportunity cost of investing in any one of them is not good. It's not good. And therefore, there is no need to invest in any one of them. This is intelligence behind the question. Okay. Finally, nothing was invested in two of the assets in the optimal solution. And when you go and check, you see that, yes, municipal bonds and CDs, nothing was invested. They were zero. How much do you think would a return for this product have to be for it to be invested in? We've answered this question many times before. How much would the return have to be? Because nobody is investing in them. And the reason why nobody is investing in them, look at their coefficient. Their coefficient actually shows that, not comparing it with any other though, their coefficient shows that the interest rates on them are lower. That is why the reduced cost is telling you that you shouldn't invest in them. So for you to want to invest in them, for you to want to produce, to invest in them, then the coefficient must go up. The interest rate must go up. Okay? The interest rate on them must increase to motivate you to want to invest in them. Right now, the interest rates are 8.5% and 5%. These two. Okay. Of course, you are allowed to increase it by only 4.5%. And this one, you're allowed to increase it by 1.5%. So the question is, how much should the interest rate be? Okay, how much would the return for this product have to be for it to be invested in? And it's simple. The return will have to be that 8.5% here plus the allowable increase, which happens to be the same. So it is 0.08. Let me do it here for you to see. So it have to be 0.085 minus that. That's it. And that is 13% for the first one. For the second one, which is a CD, you have to be this 5% minus this value, which is minus 0.15. And that one is also 6.5. So the interest rate for the municipal bonds will have to go to 13%. From the 8.5%, it should go to 13%. And then for the certificate of deposit, it is right now 5%. That one too should go to 6.5%. It is then and only then it will be juicy, profitable. It will be investment-wise to invest in any one of these. That is how you attack this question. And all the answers are here. You can see any one of them. So, okay. So that is how you got it. There is another one on stores in your work. I will encourage you to look at it, have a feel of it, have a look at it, enjoy the process of it. And then if you have a question, you can always ask. Dede? Dede, your hand is up. Unless it was a mistake.
Okay. Hello, sir.
Yeah.
Yes, please. Concerning C3, what is the overall investment for my lesson and indication, and it will not be good to invest in C1 and C2. But I'm looking at C3, even though we are not getting the optimal value. When you compare it to C1 to C2, it looks substantially good. What about that one?
C3.
Yes, sir.
Which C3? Are you talking about constraints?
Yes, about under constraint.
You look at the shadow
Using
price. Look at the shadow price.
is 0. Okay.
So that tells you that you cannot try to, take that diversification because the shadow price tells you that it's not going to help you. That's it. So always use the shadow price to make your deduction as to whether you should go for that particular constraint mix. Is that okay?
Yes, sir.
Okay, Richard.
Understand. So on the C5, today we talked about the slack and the surplus. Since the sign is equal to sign, how would we write it in a standard form? Yes. So that's my question, sir.
Well, that one, just go to this command here. Go to the formulated model. It's easier when you are looking at it from here. Okay. If you want to convert this whole thing to the standard form, count how many constraints are there. 1, 2, 3, 4, 5. So your S's will have to be in the objective function, you have to do plus 0 S1 plus 0 S2 plus 0 S3 plus 0 S4 plus 0 S5. Why? Because there are 5 constraints. Now let's take each constraint also one by one. If you take the first constraint, remember, it's a first constraint. So the slacks you are going to add is going to be S1. Now, if you want to do that, because it's less than or equal to, it's going to be X1 minus S1 equal to 14,000. That's for that one. That's how you write it in the standard form. The second one will be X2 minus X1 minus X3 minus X4. And because that one is less than or equal to, it also becomes minus S2 because it's constraint 2. S2, and then you have equal to 0. Then the next one will be X2 plus X3. That one is greater than, so it becomes plus S3 equal to 21,000. I'm sure you can follow the rest, can't you?
Yes, sir. Thank you.
Good. So that's how you write the constraint. If you look at the last one is equal to, okay? Is equal to, so that one you can choose to do plus or minus. It doesn't make any difference in that regard. Okay. I would normally do plus, and then when you find it, in fact, you will see that S5, if you make it plus, it's still good. If you move everything, remember everything that was here was eventually 70,000 in the result. So when you move that 70,000 to the right-hand side, it means S5 is going to be 0. Okay, so the slacks there was 0. And the slacks is usually 0 when the left-hand side equals the right-hand side. So that is how you handle that. I hope you get it.
Yes. Thank you.
All right. So ladies and gentlemen, that brings us to the end of the entire Kaburo. Okay. I've sent you the assignment. You should put yourself in groups. Do you already have yourself in groups?